Today I'm going to be teaching you on how to solve right triangles. Okay, so how do we solve this right triangle? So you need to be familiar with the 30, 60, 90 special right triangle. So we all know that 30 degrees, we have 60 degrees and 90 degrees because it is 30, 60, 90 special right triangle. So to prove that it is 60 degrees, we all know that the sum of all angles in a triangle is going to be 180. So therefore solving for theta, what we will have is 60 degrees. So that's why we have the special right triangle of 30, 60, 90. Okay, let's replace it. Oh no, let's write this down. Okay, now, so how we will solve its sides? So you need to be familiar with SOHCAHTOA. So I know you ever hear this. If you are in high school, you have heard it. So is just sine is equals to opposite over hypotenuse, which means the opposite of the angle, and then hypotenuse, which is the longest length in the right triangle. Cosine, which is adjacent over hypotenuse. So you can just see it, it just shorten, and tangent is O for opposite, and then A for adjacent. So adjacent is just adjacent on the theta, it's beside theta. So here is the adjacent part. If we're going to solve for, or if we're going to use the sine 30 instead of sine 60. Okay, now first let's calculate sine 30 is, actually we cannot solve it without a length. So let's put B as write a number here, let's say 12. Okay, so how do we solve for the other length? Okay, so as we can see, it is adjacent on the 30 degrees. So therefore, let's use cosine 30. So cosine 30 is adjacent over hypotenuse. So adjacent is 12 and our hypotenuse is C. So this is ADJ and that's HYP. So hypotenuse is C. Okay, now we can just cross multiply. So cosine 30, as we know in the unit circle, is root 3 over 2. So that is the value of cosine 30. So let's see. So now we can multiply both sides by 2. So 2 will cancel on the right side. We got 24 on the left. So we got this. See? And then what we can do is divide both sides by root 3. So we actually do not have a 2 here. It will cancel. Okay, so root 3. So we got this and C. So now we can rationalize the denominator. So what we will get is 24 divided by 3 and we get this. Okay, so 24 divided by 3 is going to be 8. So our hypotenuse, the length of our hypotenuse is 8 root 3. Okay. That is our longest side. The longest length on the right triangle. It's the hypotenuse. Now, how can we solve A? So we can use Pythagorean theorem. So Pythagorean theorem is just c squared is equal to a squared plus b squared. So our c squared is going to be 8 root 3, actually our c, and then we're going to square it, and a squared, that's what we're looking for, and b is going to be 144 because 12 squared is 144. Now distributing the power of 2, we will get 64 times 3 and a squared plus 144. 64 times 3, what is it? So 4 times 3 is going to be 12. We have a remainder. 6 times 3, 6, 12, 18. So we got 192 here. So we got a squared plus 144. Now we can move 144 to the left side. So what we will be having is So all it will get is 48. Okay, let's write it down. Now let's take the square root of both sides. We can cancel the invisible 2 here on the left side of the equation. So a is going to be root of 48. So square root of 48. This is divisible by 4. So let's divide it by 4. So let's do this. So 4 divided by 4 is 1. We got this and this and this. So we can broke this down into 12 times 4. And 12 can be broken down into 4 times 3 times 4. And then we can combine 4 times 4, which is 16, which is still in the radical side. Square root of 16 is going to be 4, and we got this. So this is the value of A. So that's it for this problem. Now let's try another problem. Let's say we have this right triangle. We do not have the special right triangle. We only have the hypotenuse and the other leg, which is 21. So let's call this theta 1 and let's call this theta 2. So how do we solve for theta 1? So looks like we have a hypotenuse here, and we have let's call this opposite of the theta 1. So and this is adjacent of the theta 1. So we can use what we can use in a Sokotawa. So we can use sine. Sine theta 1 is equals to 21 over 29. Theta 1 is going to be arc sine of 21 over 29. So we can use our calculator now because we cannot calculate this. So that is going to be 46 point. This is approximate value. I just rounded off, and 46.4 degrees. Okay, so now we can change our theta 1 with 46.4 degrees. Let's go ahead and do that. Okay. Now let's try the theta 2. How do we solve this? So we all know the sum of all angle in the triangle is going to be 180. So theta 1 plus theta 2 is going to be 90 equals to 180. We all know the value of theta 1, which is we calculated earlier. So we got 46.4 degrees plus theta 2 plus 90 is equals to 180. We can move 46.4 and 90 to the right side of our equation. So what we got is negative 90 minus 46.4. So let's able with this. So now we got 43.6 degrees as our theta 2. So I'm just going to replace this with 43.6 degrees. Okay, now how do we solve this thing? So we can again use use Pythagorean theorem again, and we also can do Sokotawa. But in this problem, I'm going to use Pythagorean theorem. So let's call this leg y. So we got 29 squared equals to 21 squared plus y squared. 29 squared is going to be 841. 21 squared is going to be 441 plus y squared. So let's move 441 to the left side of our equation. So I got this. We can cancel the 441 to the right side. So now y squared is going to be 400. Taking the square root of both sides, the imaginary 2 will cancel. That's not imaginary, but the invisible 2 will cancel, and this is going to be 20. So that is the value of the other leg. So we are all done. We all calculated the right triangle, and now thank you guys for watching.